Good morning, everyone. Welcome to the Avi Networks Takeoff Tuesdays webinar. Today's topic is making OpenStack ready for prime time with Avi's application security, monitoring, and analytics solution. My name is Ashish Shah, and I'll be your host. And with me is Praveen Yalagandula, OpenStack Architect at Avi Networks. Thanks, Praveen, for joining today. So let's get started. According to a recent report from Enterprise Management Associates, the prime deployment challenges with OpenStack are around performance and security. These are the primary reasons why users of OpenStack have not deployed production workloads in OpenStack environment. And in today's session, we're going to address how Avi Networks is addressing these challenges and making OpenStack ready for prime time. Before we go further, let's talk briefly about who Avi Networks is. Avi Networks has built the next-gen ADC solution enabling automation, self-service, and elastic scale. In addition to doing load balancing or application delivery, Avi has also integrated application monitoring, logging, and analytics for end-user connections. Avi is deployed in major Fortune 100 to Fortune 500 customers, including top 3 US cable providers, financial services enterprises, US e-commerce companies, and large CSPs. Specific to OpenStack, Avi has multiple production deployments with Fortune 100 customers, including multi-data centers private cloud and global CSP public cloud deployment. And Praveen here is an active OpenStack contributor. So now let's get into Avi's product. First, let's understand how Avi's technology has been built. So Praveen, can you explain how Avi's product works?
Thanks, Ashish. So Avi ADC is a 100% software solution. At the core, it's providing the load balancer as a service, but we also provide a lot more visibility and information about your applications. And the architecture itself is built on the software-defined networking principles. So you have a centralized Avi controller that's the central policy repository and analytics engine. It is a highly available cluster of VMs that provide that is the single point of integration with different orchestration services like OpenStack, vCenter, etc. And it's the one that does full lifecycle management of your load balancer instance. Following the software-defined networking principles, you have the Avi controller, and you have these small but very highly efficient high-performing load balancer service engines, these micro load balancers. Those are controlled and orchestrated by the Avi controller. And the Avi controller automatically scales them out and scales them in as needed to handle the traffic. As you get more traffic, it will increase them out and reduce them as you don't have that much traffic. And also these are created to provide you application and tenant isolation, and we can place them as needed, where needed, based on the application's needs, and we can do application affinity. And the third component of Avi controller, Avi's system, is the analytics portion of it, and we have a very powerful Avi UI that provides single point of visibility. It gives you end-to-end view of your application performance and provides an very good, very highly sophisticated Google-like search functionality for all the traffic coming and hitting your application.
Thanks, Praveen. So what about integration with OpenStack? Can we spend a couple of minutes on that?
Sure. So as I said, Avi controller talks to infrastructure as a service components, and in the case of OpenStack, it talks to Nova, Keystone, Neutron to orchestrate the implementation of the load balancing functionality. So it integrates with Keystone to automatically get all the user credentials and to do user and tenant management. It talks to Nova, Neutron to create the load balancer VMs, plug them into the right networks. And on the other side, like users can use the LBAS API to push load balancer configuration that gets stored in the Neutron and also gets pushed to Avi controller, and the Avi controller implements that load balancer configuration.
Thanks, Praveen. That sounds good. Now, what about some of the flexible deployment modes that we can be deployed in? Can we talk about that?
Yes, so since the architecture has these micro load balancers that can be instantiated anywhere, you can have very flexible deployment models that is possible with our service VM architecture. So you can have service engines in users tenant context, in tenants context, like as a here example, you have tenant 1 with 2 backend servers and tenant 2 with 1 backend server. And when they create a load balancer, when a user of tenant 1 creates a load balancer, we create these service engines automatically. The Avi controller creates them. These are again virtual machines created in tenant 1's context, plugged into the right networks, and they will attract the traffic on the blue network and load balance them to the servers. And in a different deployment model, you can have all service engines created in the admin or service users context, the service tenants context. So by having the separation of Avi controller and these micro load balancers and everything working as VMs running on top of OpenStack instead of inside or along OpenStack, we can leverage the OpenStack API and provide you lots of deployment models.
Sounds good, Praveen. So let's go into the demo now and show some of these scenarios in action. Now we're going to talk about 3 different demo scenarios, starting with SSL certificate creation and management through Horizon Dashboard. We'll talk about application analytics and monitoring built into Horizon Dashboard, and also talk about security insights. So let's get started with the first one, Praveen.
Yes, so here you have your typical Horizon dashboard, and here I'm logged into one of the tenants. And what we are going to do is we are going to look at the network topology, and to see what I'll just go through what the infrastructure do we have in this tenant. So here we have 2 backend servers, and we have the data network on which we'll be receiving the traffic, and then we have the VIP on which we will be putting the VIP, and there is a client to send the traffic. And let me switch to the load balancers tab. And we have, as you can see, we have added a couple of new tabs. Regularly you would have pools, members, and monitors, but we have added those 2 certificates and analytics tabs. And let's go to the certificates tab. And here, this is something that we added new. So you can add new certificates to your system and they get uploaded to Avi controller automatically. So let's go through adding one certificate. So I'll create a demo certificate, and we will upload key from a file. So I have a key that's in PEM format, and we uploading it, and then we need to pick a certificate. And here you can either choose to upload it as a file, or you can cut paste your key and certificate content directly into this UI. And once you have all those, basically you hit add, and then this key, it gets pushed to Avi controller, and you should start seeing that in the list of certificates available. Now, once you have this certificate, then you can associate it with your load balancer, so that with your load balancer configuration, so that the Avi starts terminating the SSL connections. Okay, so we'll add a pool. This will be your regular workflow. We'll add a demo pool, and here you can see that on the providers, you'll have Avi as one of the providers, and we pick up a subnet. We choose HTTPS, so that we have an end-to-end SSL here. And you can do have front end with SSL termination and back end just using non-HTTPS traffic. That's possible too. So we have added a pool. Now let's go ahead and add some members. So we have a couple of servers that I'm going to add, both of them to the pool that we created. And we'll use 443 as the protocol port for HTTPS. So we have those two members added to the pool, and the next step of regular load balancer workflow is to add a VIP. So we'll add a VIP to it. And here we will provide pick an IP address. And give a protocol port, again 443, because we want to have HTTPS on the front side. So we'll pick the protocol as HTTPS. And then that's it. So at this point, once we create the web, the Avi will start to implement this web. Now, once we have created this web, if you look at in the drop-down box, you will see that associate certificates. These are a couple of new links that we have added so that you can associate certificates with your web. So you click on it and you can choose a certificate for your web. And we also have a place to choose a pool certificate that will be used by load balancer as a client certificate when talking to your backend server. And this is useful in cases where your backend server accepts requests only from pre-configured clients. And so now you have the load balancer instance with certificate configured. And let me switch to the topology just to show what happens here. So in this case, Avi controller essentially insert this service engine with one leg into the data network and one leg into the VIP network and provide load balancer. So the traffic coming from the client or anything will go to the load balancer and they will be load balanced to the backend servers. So let's go to this client and send some traffic, and we'll do a curl to this, and as you can see, now the traffic is flowing through.
Sounds good, Praveen. So because we have integrated this with Horizon, it's a single place to upload the SSL certificates.
That's right.
Great. Let's switch to the second demo now.
Okay, so let's switch to the another project where we have few more load balancer instances, broken link pool and scale out pool, and these have a little bit more traffic running through, so we can look at different things on these load balancers. Note that we have added these another tab called Analytics tab, and that Analytics tab essentially shows you deeper visibility of the traffic coming to your applications. And this is the main dashboard page for our Analytics tab, the newly added Analytics tab. So here you get to see both your virtual services, the VIPs and pools that are configured, and all the servers that are there. And this provides a overall view of all your load balancer instances. Yeah.
Sounds good, Praveen. It looks like there are two virtual services here mapping the two load balancers there. And I see color-coded objects here. Can you explain what the orange and the yellow and the green mean here?
Sure. So the color encoding, we are basing it on the health score of these individual virtual services. So we compute a health score for every virtual service based on collecting a lot of information about this application. And we collect information about how well it is performing and different information about resources, and we do collect information about any changes in the normal behavior of the application, and do some security penalty if it is not configured properly, and compute a comprehensive health score for each application, which is what we show here.
Right, so it's not just a binary up or down. It computes the health score not just based on current performance, but also if there is any risk in terms of resource utilization or anomalous behavior or a security misconfiguration or attack. That sounds good. Can we go deeper into the analytics next, Praveen?
Sure. So let's switch to the go into the details of a virtual service, and as you can see, the main panel for analytics is this end-to-end timing, and this gives you a very good picture of how well your application is performing end-to-end. On the leftmost, you have the client and the client RTTs observed by the clients, and then you have like the RTTs seen by while going from load balancer to the server, and the RTTs and the application response time that shows how long it took for the application to respond to your request. And these are all average values over like whatever time frame that you pick. And you have a data transfer time that shows how long it took for the response to go back to the client. And you have this entire picture that giving right at a glimpse how well your application is doing across all your requests.
Sounds good, Praveen. So if we need to go deeper into individual transactions, this is the average application performance visibility. What if we want to go into the details of individual transactions? Can we go into that next?
Sure. So let's switch to the log screen, where you can see information about each individual request at a very fine granularity. And by default, we collect logs for only the significant logs, the ones that we consider are important. Maybe some of them have some errors or something. And here you can see like a 404 error and so on. And you can click on the non-significant logs to get all of them. And in this case, we basically have all these logs. And you provides this interface provides very fine-grained search-like functionality. So I can type something like iPhone to get the list of all requests that were that correspond to accesses from iPhone. And you can look at more fine-grained information about each of these requests, like where it came from, what kind of version, SSL version is used, what kind of certificate is used, what kind of browser was used, or more details of the request, and a lot more details. Or you can see which backend server was used, was responsible for serving this request. And
sounds good. Yeah, that's excellent. And what else can we do with this analytics dashboard?
So the other things that it can show is like you can do more aggregated analytics. Like you can look at an end-to-end timing, and you're basically looking at end-to-end timing of all the requests that came from iPhone, or you can look at all these different other parameters. Like you can do more aggregated analytics on top of them. And you can see here that there are some requests that have got pretty high latency, so you can click on them and directly dive deep into those requests that got those high latencies. And for those, you can drop down and see why that's happening. And you can see that, this one has very high RTT because this one probably coming from a user in India. And that gives you a very good view of why certain requests are not doing well.
Right, yes. Basically, you can find out if there's a network issue or an application issue or any kind of issue, and root cause those type of issues very easily.
That's right. So let's take out these filters, and now let's look at, you have all these requests. So let's look at only those requests that have some errors.
Right.
And here I'm looking at all these that have 404 errors. So you want to see why you have all those 404 errors. So you can try to figure out, you can see that most of them seem like URI example.jpg. So you go click on the URL path to see if that is the cause, and you can see, yes, that is the cause. And then you don't know, whether it's missing on all of the backend servers or if it is missing on few servers. So you can click on the server request by server IP address, and you'll see that there is just one backend server where that example.jpg is missing. So that it allows you to quickly hone down to your problem and root cause the issues.
That's very powerful, right? Because not only we are providing visibility, we can actually help admins figure out where the problems are. And these are the kind of solutions that the OpenStack cloud architects are looking for so that they can feel comfortable deploying production applications in OpenStack.
That's right.
That's great. So why don't we move into security details? Now I see there's a security tab there. Can we dive into that and see what that offers?
Sure. So let's go to the security tab. Okay. So in the security tab, we showcase what the security, how well your application is in terms of the security. On the top left panel, we show details about your SSL characteristics of your application. Like here, it's showing that all 100% requests have perfect forward secrecy, which is a good thing. And if you have like requests, you don't want any requests with non-PFS, which is not that great. Like you don't want to have requests that are vulnerable or the data that you might leak.
Right, that's important because recently when Apple announced iOS 9, they mandated that all their applications must use PFS. And that's a big issue for many of the traditional hardware load balancers.
That's right. So this gives a very good view of how well your certificates are, like how distributed your certificates are, and allow you to see if there are any bad certificates, then you can go take them out.
Sounds good. What about the next pie chart?
Sure. So this next pie chart shows the TLS versions, different TLS versions across your requests. And at the bottom, we have the SSL score, where we score your application based on different categories like PFS support, SSL protocol strength, and so on, and on a scale of 0 to 5. And here you can see that one of the things where we dinged one point is trusted CS certificate, where this application is using a self-signed certificate instead of using a properly signed certificate.
I see. So this is a very easy way for you to know whether the application is properly configured, and if it's not, then we'll give you as a penalty on the security score or SSL score that's reflected in the health score.
That's right.
And I see another panel on the right about DDoS attacks. Can we talk a little bit about that? Although I see that on this session, we don't have any attacks going on. Maybe we can switch to another environment where we have simulated some DDoS attacks and go deeper into that.
Sure. So let's look at this another window where we are sending some more traffic with some attack traffic. So let me log in. Okay, so this is again one web where we have a lot of traffic going on, but there are a bunch of L4 and L7 attacks, like 34 requests per second, that are basically the attack traffic. And this, we automatically capture all the requests and all the type of requests, like counts of them, and show you on these nice pictures. And you can deep dive into the attacks, and you can see that there are significant number of SYN floods and DOS HTTP errors and so on. Not only that, this pane also allows you to automatically block some of the IP addresses that are generating these bad traffic for you. So this provides a single pane from where you can manage and control your DOS attacks, and allows you to gives you great a powerful tool.
That sounds good, Praveen. So it looks like with these added features in Avi's Horizon Dashboard, the OpenStack admins can not only provide load balancing and high availability, but also provide application monitoring, analytics, and security services.
That's right.
Thanks, Praveen. So that ends our demo. To summarize, Avi makes OpenStack ready for prime time with its integrated security, monitoring, and analytics solution that's integrated into Horizon, along with its full-featured load balancing or application delivery features. And our customers can guarantee tenant isolations and application SLAs in a multi-tenant production OpenStack environment. And if you want to get your hands dirty, you can go to avinetworks.com and start your free trial. You can download Avi Networks code into your lab environment and play with it. Also, we are going to be at OpenStack Summit in Tokyo next month, and we'll have one of our enterprise customers speaking on stage live in a fireside chat. And we'd love for you to come and say hello to us. You can reach out to me if you want to set up meetings at ashish@avinetworks.com. Again, thanks for joining.